So in this presentation, we're going to talk about the project that we made, which is a scaled down metal bridge that can deploy from one side to another. I'm Abdurrahman Al-Watabi.
I'm Nick Bryce.
Saeed Al-Ajmi.
I'm Jake Tanzilla.
So the contents of this presentation is the intro. We're going to talk about the purpose of the project and why we made it and what are we trying to accomplish. And we're going to talk a little bit about the background of bridges safety. And we're going to discuss our methods and materials, basically the steps we made and the tools we needed to accomplish the project. And we're going to discuss our results, and we're going to summarize everything in the conclusion. So the purpose of this project is basically back in 2016. In Wheeling, West Virginia, there was a bridge that got destroyed by floods and left shoppers at a shopping center stranded at the other side of the bridge. So our project is basically going to be a metal bridge that works as a temporary bridge in case of emergencies, that can deploy from one side to another, that can help shoppers get to the other side safely. And the bridge, so our little prototype is basically has to be a bridge that can deploy from one side to another while holding 2 pounds on it, and it can support 2 pounds after it's stretched out. So a little background on the safety of bridges is back in 2016, Dr. Sami Tabash and Dr. Wissam Najm in the University of Sharjah in the United Arab Emirates reviewed 12 papers on bridge improvement. They studied bridges after natural disasters, and they noticed that most damage on a bridge happens to the cables. So in our bridge, we're trying to make a bridge that does have a little to no cables on it, so it would be much safer in case of natural disasters.
On construction, the bridge was constructed originally using 3 sheets of metal that we cut in half. This way we could stack the metal on top of one another and hopefully double up the strength of it. From there were holes drilled into each end of the metal, roughly an inch in from the outside. This way, later on, hex bolts could be weaved between the metal so that it could extend out to form the bridge itself. After that, a wooden base was constructed in the shape of an L to serve as the base and attached to the table. From there, a hinge was screwed into the wooden part of the base and then weaved into the other end of the metal bridge using zip ties. The last step was just tying a cord to the top of the bridge so that we could use it to extend out the bridge and then later retract it.
Our results. Our bridge was successful in some of the cases, but unsuccessful in others. At first, our bridge was collapsed down so it would fit into the 16-inch box, which it was successful at, and then we would take it out and extend the bridge where it would be the full 3 feet long. But as we tried to deploy it, it was not as sturdy and it would kind of fall to the side due to a weak hinge and some loose bolts. And our wooden base would clamp down to the edge, and our bridge did successfully deploy, but it was not able to hold the 2 pounds as it deployed due to the fact that it stood straight up and went down. After it was deployed, we could hold the 2 pounds in the center, which simulated people walking across it. And after we started to add weight, it was doing good until we got to 12.5 pounds, and the flexion of the bridge was too much, where one side of the bridge fell off and collapsed down.
The bridge was made of metal blades connected with bolts attached to wood base with the hinge and zip ties. In theory, the metal blades were supposed to handle the weights applied. But when we started to experiment with the bridge, the metal blades start to bend upward the more we add weight. Because we used a thin metal, the bridge could only hold 12.5 pounds before it collapsed. The simplest solution was to use a more durable material. In conclusion, the project could help to find solution for emergencies by acting as a temporary bridge when natural disaster occurs. We couldn't deploy the bridge while 2 pounds were on top of it, but the bridge successfully held 12.5 pounds. In the future, the bridge could rebuild using more durable material. Thank you.